Welcome, Market Rebels! Last week we found that to succeed in markets, it's not about predicting the stock's price. It's about predicting what others think. It's a game of expectations. This week we're going to find out why anticipating beliefs is far more difficult than it sounds. Looking for loot in mind-bending market math. Traders treat price charts like treasure maps. They draw lines, mark X's, and argue about which formation means gold ahead. They're convinced that if they just squint hard enough, the future path of the stock will reveal itself. Charts are drawn, targets are set, confidence is projected. We see candlesticks meander through time as if the market were bound on a specific route to the closing price, like the M42 bus scheduled to stop at Grand Central Station. That's why narratives are so easy to attach. Once we see the outcome, it's easy to explain why it worked out that way, and that gives traders confidence they can do it tomorrow. If you can guess the right route early enough, the thinking goes, you'll find the gold. Traders confidently say things like, "I've seen this pattern before, so it's most likely going to rise after it breaks this line." It sounds possible, and who doesn't want to get rich from cracking the code? Markets are studied relentlessly. We have over 100 years of price data, advanced mathematical models, and armies of analysts. Today we can add machine learning and artificial intelligence. We can send a rocket on a path to Mars, so why can't we predict a stock on the path to the closing bell? It sounds like a good thought, but here's the most surprising prediction. No matter which pattern you see, I'm sure you've never seen it before and never will again. Why? Market prices are not paths. They are the result of a branching process. At every moment, multiple future price paths are possible, even though only one is realized at the closing bell. Once you understand how a branching process works, you'll see the markets don't hide treasure at fixed locations. Instead, they change the map every time someone looks at it. And sometimes, markets move the treasure while you're still digging. Traders aren't necessarily bad at seeing or understanding randomness. The problem is that most of it's out of view, and it's always easy to overlook the things you can't see. You can't see infrared rays, but that doesn't mean they're not there. In a similar way, many stock paths can emerge from a branching process, but you'll never see them. Not seeing or understanding the process doesn't make them go away. It doesn't make them harmless. It makes them easy to ignore, and that makes them dangerous. So rather than talking about the stock price path you see, let's talk about the infrared spectrum, the ones you never see. Branching creates new future paths. At every moment, the market doesn't move in a single direction, even though the end-of-day chart pattern makes it look like it does. Instead, it does something sinister. It branches. A trade executes, a quote disappears, a stop triggers, an algorithm reacts, and a new quote appears. Each event puts price on a new path and changes the probability of what can happen next. The future is created as it's moving, and that's the idea behind branching. It's a hard concept to grasp and impossible to visualize, but we're going to try. So let's look at some fun ways to understand why a branching process won't lead to treasure, but will lead to mind-bending math. There are two basic types of random processes, static and branching. A static process is like shuffling a deck of cards. Once shuffled, the order is determined. As you flip the cards over one at a time, the order doesn't change. Instead, you're just revealing what is now 100% determined. However, that doesn't mean it makes the process of shuffling cards trivial. After you've revealed the sequence you created, it looks random and chaotic, but it's special. It's never been seen by anyone in the past and never will in the future. Ever since card games were first created in 15th century France, if you were to log all shuffles in the history of the world, the one you're seeing now has most likely never been seen before. How is that possible? There are only 52 cards. Well, that's exactly the problem. The number of combinations from 52 cards is a number so astronomically large, it's hard to imagine. It's the number 8 followed by 67 zeros. Just how big is that number? Astrophysicist Neil deGrasse Tyson came up with a great way to understand it, or at least try to. As you'll see, saying there are 67 zeros is one thing, truly understanding it is another. But here we go. Since the beginning of time, if we had a billion civilizations, each with a billion dealers, and each dealing 1 billion shuffled decks per second, the universe wouldn't be old enough to see two matching card decks. You'd need to replay the universe trillions and trillions of times over. Mind-bending, but we're just getting warmed up. That's a lot of combinations, but notice that as you're flipping cards over one at a time to reveal the sequence, you're not branching into a new path. Once the deck is shuffled, the order never changes, and that's what makes it static. Stock markets, however, don't behave like that. Stock markets are adaptive systems. Every time a new price prints, the stock market branches to a new price. So all future potential prices depend on what happened in the past and what happens next. If you think the number of combinations for card shuffling hurt your head, on a scale of 1 to 100, it was a 1. So let's make a super simple stock market to demonstrate the astonishing power of branching. The market is open for 6.5 hours per day, or 390 minutes. Let's assume that the stock opens at $100 and prices are equally likely to change by 1 cent up or down every minute. It's like we're flipping a coin to determine the new price. So at 9:31 a.m., the stock will either be $99.99 or $100.01. 1 minute later at 9:32 a.m., we'll branch to a new price that's either 1 cent up or down from the current price. What will that price be? It depends on the current price. If the current price is $100.01, we'll either be at $100.02 or back to $100. But if we landed on $99.99 after the first minute, the next price will either be $99.98 or back to $100. We don't know the new price as it depends on the previous price. That's the key to understand. This process continues until the closing bell. Now here's the question for you to think about. How many possible paths are there in this ridiculously simple stock price model? Do you think you'd be able to predict or even get close to the final number? Would you have a good chance of predicting that final price? Just like shuffled cards, it's insanely hard to describe, only much, much harder. The number of possible paths is the number 25 followed by 116 zeros. That number is vastly larger than the number of seconds since the Big Bang, the beginning of the universe. It seems hard to imagine, but time is like shuffling cards. It's static. Each second just adds one more second to the total. It doesn't branch to new possible states. So that's why the number of stock price paths can dwarf the very large number of seconds. Now, if you really want to make your head hurt, let's try a different comparison, and you may want to be sitting down for this one. 1 light year is the distance light travels in 1 year. Considering it moves at 186,000 miles per second, it's far. It's nearly 6 trillion miles. At 60 miles per hour, it would take 11 million years to drive 1 light year. So remember to pack a few snacks, and new tires, and a new species. The observable universe is about 93 billion light years. That's hard enough to imagine, but here's where it really gets tricky. Try to imagine the number of atoms in that observable universe. To do that, you must have some idea of just how small an atom is. That new pencil sitting on your desk probably has 10 to the 23rd atoms. That's a 1 followed by 23 zeros. If you could count 1 million atoms per second, counting the number of atoms in that pencil would take about 3 billion years. That's just one pencil. Try to scale that out for every object and every planet for 93 billion light years. It's not even conceivable. Your brain will quickly blink overload if you try. Ready for the punchline? The number of possible stock price paths in our simplified 390-minute stock market model is about 10 to the 37 times bigger. That's a 1 followed by 37 zeros. To try to put that in perspective, the probability that you guess the day's price path would be the same as correctly guessing every card in 2 shuffled decks. Or, if you like state lotteries, for a pick 6 from 49 lottery, you'd be just as likely to win 17 times in a row as to guess the path for our simplified stock market model. Predictions fail not because traders are bad at forecasting destinations, but because destinations are not the problem. The problem is the chain. It's the branching process. Each step doubles the past history, and that's why probabilities explode in complexity. Even if each individual step is only mildly uncertain, chaining thousands of such steps together produces overwhelming unpredictability. Small differences early in the sequence can cascade into dramatically different outcomes later. 2 price paths can start at $100 and end up worlds apart after 390 minutes. But things get even worse for real markets. Market complexities magnify potential paths. We don't have one price change per minute. We have hundreds of thousands or millions per second. That's only the beginning of the trouble. Just like our 390-minute model, each price change depends on the previous one. But there's another layer of trouble for the actual stock market. Each new price changes traders' behaviors. Markets are adaptive systems. Traders do not passively watch trades, they respond to them. So these branches are not independent. They feed back into one another. A large trade does not simply change price, it changes beliefs. Each branch represents a decision. A trader buys, another sells, a market maker widens spreads, an algorithm pauses, a stop order triggers. The future probabilities are altered by the present action. The probability structure of the market evolves in response to its own outcomes. It's like trying to solve a Rubik's Cube, but with the colors changing as you move. By the closing bell, the final price is known with certainty. But getting there requires navigating thousands of conditional events, each reshaping the landscape for the next. The market path we see is only the version that survived. Behind every price chart is a silent universe of near misses, trades that almost lived, erased when the market blinked a different way. The closing price is not a prediction fulfilled, it's the lone survivor. The market doesn't choose the best path. It simply erases the others and then dares us to believe it was obvious. So indicators such as RSI or MACD feel informative because they compress history into a narrative, not because they isolate a predictive signal. You will never be able to predict the market's path, and you certainly can't control it. But you can control your exposure to being wrong. That's why options matter and why they're crucial for today's markets. The market reveals one path, but options price the entire invisible tree beneath it. They don't just hedge what happened, they hedge what might have happened. They hedge the paths that never came to be, the branches you never got to see. Next week, we'll look at why traders struggle to make money. It's not that they're necessarily bad at picking good stocks, they're measuring with the wrong ruler.